Hello everyone. Welcome back to the lecture series of creating data science and artificial intelligence. Okay, so we are first covering artificial intelligence topic. So we have covered DFS, BFS, DLS, and iterative deep learning depth first search, and what are the difference between them. We already covered in the previous lectures. So in this lecture, we are going to discuss about uniform cost search. Okay, so let us see what is uniform cost search is. So, uniform cost search is an uninformed search algorithm that uses the lowest cumulative cost to find a path from the source to destination. So, one important point to note here, that is lowest cumulative cost, not just the lowest cost. It's the lowest cumulative cost to find a path, and that is from the source to a destination. Okay. Nodes are expanded starting from the root according to the minimum cumulative cost. According to minimum cumulative cost. The uniform cost search is then implemented using priority queue. So in the case of BFS, we have discussed queue data structure, but in the case of uniform cost search, we have called something priority queue. So what is priority here? Like basically particular nodes or elements are given priority, but based on what? Based on this cumulative cost. Okay, so we'll discuss this with the help of one example. Okay, now let us take one simple example. Suppose this is my starting point, this starting node. Now I can go from S to A to B, then from S to C, C to D. Say now from S to E to F, and say suppose this is my goal state, that is G. Okay, and say for example the cost associated with the path is 1 3 3 5, and say for example you can consider 5 to 1, right? This is 5 to 1. Now in this case, how to approach this particular uniform cost search, how to apply uniform cost search algorithm to this particular search space. So this is our start points, that is source. This is our goal state, that is our destination. Now I want to go from S to G with the minimum cost, right? So how this works, let us see. So for this case, we are considering something called frontier. So we already discussed what is frontier and what is explored state in the first or second lecture of DFS. So frontier is basically the nodes that we are going to explore, right? We are going to see whether it is my goal state or not. In explore is basically we have checked that particular node is goal state or not. Okay, so we discuss that. So first we start with the S. Okay, so in the frontier our S will be there because that is our starting point. But from S, so we'll see whether this S is my goal state or not. It is not my goal state. So from S, I can go to A, I can go to C, I can go to E. So I have explored this particular node S, I'm removing it and I'm adding it in the explored. Okay. Now from S, I can go to A, C, E. Now I can add A having the cost 1. So we need to give cost also. Then C, from S to C, I can, it will take around 3 units. From S to E, it will take around 5 units. Okay. Now in my frontier, there are 3 nodes A, C and E, which I can go from S. But which one we have to take the next? So here we are following priority queue. So in the queue, so this is our queue, right? So we have to take that node which is having higher priority. So which node is having higher priority? Which is having the lowest cumulative cost. So in this case, A is having the lowest cumulative cost. So let us explore A. So whether A is my goal state or not? No, A is not my goal state. So I'm adding A in the explore, that I already visited this particular node. I have already explored this node, right? I am removing A from frontier. But from A, I can go to B. Okay. Now I can add B here in the frontier. But what should be the cost? What should be the cost? In this case, B. So here in this case, if you see, we have to consider lowest cumulative cost from the root node. Okay. So here from S to A to B, we cannot go directly to B because we have to go through A only, right? So in this case, in order to reach to B from S, we required 1 plus 3, that is 4 unit. So cost associated with this particular node is the summation of 1 plus 3, okay, that is a previous explored node, okay, through the path that we are coming. So that is basically 4 here. It's a cumulative cost, not a 3. Okay, so please keep a note of it. It is very important point, right? Now once we added B in the frontier, now look at the frontier queue. So which one is having the lowest cost? Which node will be given priority? Basically C, because C is having the lowest cost, right? Then I am exploring C here. Now whether C is my goal state or not? No, it is not my goal state. Then in that case, from C I can go to D. But at what cost I can go to D? 5 or 8, that is cumulative cost, right? That is 8, 3 plus 5. So I can go to D. At what cost? At a unit of 8, right? So I have explored C, so I can remove C here. Now in the queue, I have E, B, and D. So which one is having the lowest cumulative cost? B. So I'm exploring B, whether B is my goal state or not. B is not my goal state, right? So I have already explored this B. But do we have any other node to explore after B? No. So here we have reached the dead end. So we don't have any other nodes to explore, right? So that's why we have already explored and we don't have any other node to explore. So we'll remove uh, B from the frontier and we don't need to add any node because we don't have any other node after B, right? Now in the frontier, D and E is remaining. So which one is having the minimum cost? E, right? So I'm going to E here in this case. So from E, right? Now from E, I can go to F, but at what cost? From S, 5 plus 2, that is 7. So I can remove E, I can add F at the cost of 7, right? Now whether D or F. Now I have remaining two nodes, that is D and F. Now in this case, which one is at minimum cost? F again. So I will explore F. F is my goal state or not? No. But can I go to G? But yes. But from F, I can go to G. But at what cost? Through S, 5 plus 2 plus 1, that is 8 at a cost of 8. So G, the cost of 8, right? So we have explored F and we have added the frontier G. So we have two elements remaining in the frontier, that is priority queue. But in this case, both are having the same cost. So what to do in this case? So in this case, you can take any node, either G or either D. Okay, let us take first D. So if we take first D, we don't have any other node to explore and this is not my goal state. So our algorithm will not go beyond this point, so it is a dead end, right? And it will remove the node from this frontier because we have already explored this, right? I will add in the explore state. Now the next node is G. Whether it is my goal state or not, yes, it is my goal state G, but at what cost? 8. Now this 8 comes from which path? From S to E, E to F, and F to G. That is 5 to 1. Okay, so this is my optimum path to reach the G from S at cost of 8, right? So this is how cost search algorithm works. And even in this case, if you consider G first, so what will happen? G is our goal state, right? So we have reached our goal state. But in this case, our algorithm will not stop, right? If you remember the DFS and BFS, in that case, our algorithm will get stopped once we get the goal state or destination. But in this case, the algorithm will not stop unless this frontier is empty. So in the frontier, we have one more node, that is G here. Sorry, that is D here because we already explored D. So then again, it will explore D whether it is goal state or not. Or not, then it will stop the searching, right? So unless frontier is empty, this uniform cost search will continue to search even after getting the goal, right? Because there can be multiple way to reach a particular goal and which is having the minimum cost. So we'll discuss that one example also. Don't worry about it. Okay. So I hope you understand this particular example. Okay. So one important point to note is that we have to consider lowest cumulative cost here, right? Now let us take one more example. Okay. Suppose I am in Mumbai. This is Mumbai. Now I want to go to Pune. I want to go to Pune from Mumbai. Okay. So the one thing I can do, I can go to Goa first. So for example, I can go to Goa, and from Goa I can go to say Nashik. Okay, and from Nashik I am going to Pune. Okay, so this is like this, from Nashik and going to Pune. But the other way I can go is from Pune to Thane. Sorry, from Mumbai to Thane, right? And from Thane I am going to Pune, right? But at what cost? From Mumbai to Goa, it will take me around say 6 costs, so 6 hours. Say for example, from Goa to Nashik, say for example 5 hours, and from Nashik to Pune, say 1 hour. From Mumbai to Pune, say 1 hour, and from Thane to Pune, it will take me around, say for example, 10 hours. Okay, say 12 hours. Okay, so this is our search space. Okay, this is our search space. Now we need to find out the optimal path, right? So in this case, we can easily find out like 1 plus 3, that is 13, and here 6 plus 5 plus 1, that is 6. So this will be our optimum path, right? But how to uh, find out? By using uniform cost search, right? So same thing, same method we'll consider, that is frontier and that is explored state, right? Now which one is frontier? That is Mumbai first. So whether it's a Mumbai is a destination or not, no, it is not a Pune. So I am removing Mumbai. I'm adding it in the explored list. So we already explored Mumbai, but for Mumbai I can go to Thane or I can go to Goa. So which one will be added first? We can add Thane at a cost of 1 and we can go to Goa at a cost of 6. But out of this Thane and Goa, which node we have to visit first? So which one is having the lowest cost? So here which node will get the priority? T node, right? That is Thane. So we can go to Thane first at a cost of 1. But from Thane, where I can go? I can go to Pune. But at what cost? 12 or 13? 13, because we have to consider lowest cumulative cost. It is cumulative cost, right? So in order to go to Pune from Mumbai via Thane, it will require 13 units, right? So I can add Pune equals to 13 units. I will remove this because I already explored. Now in the frontier, we have G and P. So which node will get the priority? G, because it is having the lowest cost. So I'm going to G here. Now from G, I can go to Nashik, but at what cost? At a cost of 11. 6 plus 5, that is 11, right? Then I can remove G from the frontier, and I can add Nashik at a cost of 11, right? Now which one is having the lowest cost? Nashik, that is 11. So again I will go to Nashik, that is 11 cost, and from Nashik I can go to Pune, but at what cost? 12. So here I can add P 12 in the frontier. But if you see here, P is already present at a cost of 13, and here we are adding P at a cost of 12. So we need to consider the lowest cost. So we'll take the P first, that is 12. Okay. P, now P is my the destination, that is my goal state. So I have reached the Pune at a cost of 12. Now how this cost 12 comes up? By this particular route, by Mumbai to Goa to Nashik to Pune. All right. So that is 6 plus 5 plus 1, that is 12, right? So this is my optimum route, right? So here in this case, if you observe, I am exploring more a number of state in order to reach to Pune, but here in this case, in the case of Thane, there is only one state. So uniform cost search will not look at the number of nodes you are having. It is basically look at how much cost it is taking to reach that particular state. Okay, so that's the important part you have to note. I will also mention this in the summary chart. Don't worry. So I hope you understand this particular example. Now let us take one more example which is more complex than this. Okay. Okay. Now let us take one more example. Okay. Suppose this is my goal state, sorry, source state S. From S I am going to A. I can go to B. From A I am going to C. From C I am going to D. Okay. So for example, D I am going to E and F. Okay. So from SA, from S to B, from A to C, from B to D, say from D to C, C to E, D to E, and F to E. Okay, so this is the directed graph. Okay, and say cost is 1, 2, 3, 4. This is 1, and this is say 2, 3, 4. Okay, this is my search space now. Okay, so this is my search space. Okay, our goal is to reach F from the S. So this is our initial state S, and this is our goal state S by using uniform cost search, right? So I can go to by this way, I can go like this also, or I can go like this also, right? Now which one is the optimum path? So let us find out in this case. So same thing, consider frontier and explode list. Okay. So first is S, right? So whether S is my goal state or not? No, S is not my goal state. So I will remove S. I will add in the explode list. But from S, I can go to A and B. But at what cost? At a cost of 1, at a cost of 2 to B, right? Now, among this frontier, which one is the next node we have to explore based on the priority queue, which one is having the lowest cost? So which one is having the lowest cost here? A. So I can explore A here. I can add A here. Whether A is my goal state or not? No, A is not my goal state. But from A, I can go to C. But at what cost? The cost of 4, right? From S to A1, A to C3, that is 1 plus 3, that is 4. At a cost of 4, right? I'm removing this A and I'm adding C node here at a cost of 4. Okay, now we'll do one thing. Let us try to visualize this graphically. Suppose this is my source, and from source first we have explored S, then from S we have gone to A at a cost of 1, right? We have gone to A from the cost of 1. We have explored A. From A From A, I can go to C at the cost of 4. So I'm adding C in the frontier. Now, which node will be the next node? Based on the priority queue, that will be B because B is having the minimum cost. So I need to go for B here. Then I'm exploring B state from the S, right? That is B here. At a what cost? At a cost of 2 here, right? Now, from B, I can go to D, but at what cost? 2 plus 4, that is 6. So that is 6. I'm adding in the queue. I'm adding in this in the frontier. I'm removing B from the frontier because we already explored. Which node we have to explore? C or D? That is C because having the lowest cumulative cost C. So from A, I can go to C, right? From the graph, you can see I can go to C now here. That is C, right? Now at the cost of 3. Now total cost is 4 here, right? For C, total cost is 4. But from C, I can go to E or D. I cannot go to D because arrow is like this direction. I can go to D to C, but not C to D. But I can go to C to E, right? So from C, I have already explored this particular node C, so I can go to E. But at what cost? 1 plus 3, that is 4. So I already reached the C node with the cost of 4. But in order to reach to E, I need to spend 2 more unit. That is 6. That is 6 unit in total, right? So which one is having the lowest cost here in the frontier now? Both are having the same cost, right? That is 6 and 6. Okay, now we can consider any node, either D or either E. Let us take a D first. Now if I take D first, so from D I can go to C. Okay, at what cost? That is 2 plus 4, 6 plus 1, 7. But I already explored the state C at a cost of 4. So I cannot go to, so we'll ignore this particular node because the cost is high and we already explored this particular node, right? Now from D I can go to E also, but at what cost? 2 plus 4 plus 3, that is 9, right? But I am already having the E in the frontier which is having the lowest than the 9, right? So we also ignore this part. So we are exploring this D and we are not going to any other path here because we already explored all the paths, right? We already having the nodes, right? So you can also add E12, E9 here, right? But the lowest is having E6, so we'll go with E6 because we already because we have to follow the lowest cumulative cost, right? So we can remove this E node from this frontier. So I will explore E now at a cost of 6, right? E at a cost of 6 from where? The 6 we are getting from C. So from C like this. But from E I can go to F at what cost? 6 plus 4. It is 6 here. 6 plus 4, that is 10. So I can go to F 10. So the next element will be F. So I am adding F in the explore state and we already explored the node F at a cost of 10. Alright, this is cost of 10. So this is my path. S to A to C, C to E to F. This is my cost. This is my path. That is S to A to C, C to E and E to F at a cost of 10. This is my optimal path, right? So in this case, you can see we get the optimal solution, even though we are having the 3 more ways to reach this particular place. Now there are two things to note here. First thing is that in this case, we have we have 3 paths, right? From which I can go S to F, but here we get the optimal path directly. Suppose if we are having one more path here, say for example, S to B, B to D, D to E and E to F, right? Suppose this is one more path and here the cost is 8. For example, let us say cost is 8. Then in this case, they will compare the final path, okay, final cost, and it will give us this result because it will compare the lowest cumulative cost among the path, right? That's what we have discussed in this here. The uniform cost search is then implemented using the priority queue. Now here you can see nodes are expanded starting from root according to a minimum cumulative cost, right? So which path is having the lowest cumulative cost, that will be uh, found, right? That will be projected first. So in this way, we'll get the optimal path in the case of uniform cost search. Okay. So I hope you understand this particular example. I think this graph is more clear how we can go to particular node, okay, rather than the previous example. So let me know if you have any doubt in this particular case. Okay, so whatever we have discussed till now, we'll just go through it. Uniform cost search does not care about the number of steps that a path has, right? So in the second example, we have discussed this. but only about their total cost, right? It doesn't matter how many intermediate nodes you are having unless the cost is minimum, right? Therefore, it will get stuck in an infinite loop if there is a path with infinite sequence of zero cost action. So remember this point, okay? If you sources, it will not specify this particular condition, but yes, uniform cost search also can get stuck in the infinite path when there is a path with the infinite sequence of zero cost search. This is an important point to note. Uniform cost search is guided by path cost rather than the depth. Yeah, so we have seen this. So its complexity is not easily characterized in terms of B and D. So we cannot say whether it is order of B to the power D or B into D, right? In the case of DFS and VFS. Okay, so then what is time complexity and space complexity in this case? So let us consider C star be the cost of optimal solution and assume that every action cost take at least epsilon cost. Okay, then the algorithm in the worst case the time and space complexity will be order of b to the power 1 plus c star divided by epsilon, right? So this will be the time and space complexity of uniform cost search, which can be much greater than b to the power d. Now how this can be much greater than b to the power d? So for example, let us take we are having this node that is S and say this is my node G. It is taking me cost like I can directly go to S to G by at a cost of say 90. But I am going to A, then A to B, B to C, C to D, DE to F like this at a cost of 1, 2, 3, 4 till say M at a cost of say 1. And then after that from M I'm coming back to this particular node G. Suppose the total cost of this particular path is 80, right? Now, in this case, what happened? The time and space complexity, right, which can be much greater than b to the power d itself, right? Because this will not consider the depth; it will only consider the cost associated with the particular path, right? So the time complexity and space complexity will be different in this case. So please remember, right? So it is equals to order of b to the power 1 plus c to the power c star divided by epsilon. Okay, so please note this. It is very important concept. When all steps cost are equal, then b to the power 1 plus in bracket c star divided by epsilon is just b to the power d plus 1. So when the steps cost all are equal, say for example in the previous case, if we consider 1, 1, 1 for all the path or any 2, 2, 2 like same cost, then in that case it will be order of b to the power d plus 1. So here you can also it is much greater than b to the power d, right? When all step costs are same, uniform cost such as similar to BFS. That is the important point. The question can be framed from this particular point. When all steps cost are the same, uniform cost search is similar to BFS. What is the condition when UCS is equals to BFS? When all the steps cost are same, right? Except that data stop as soon as generate a goal. There is one thing like in the case of BFS, as soon as our algorithm find the goal set, it will stop searching. But in the case of uniform cost search, it will continue to examine all the nodes at the goal step to see if one has the lowest cost or not until the frontier is empty, right? So that is the key difference in BFS and UCS. Thus, uniform cost search does strictly work by expanding the nodes at a depth unnecessarily because the time and space complexity in the worst case will be much greater than BFS and DFS. Okay, so I hope you understand this particular example, whatever we have discussed today. Just go through these particular points once again. Try to understand with the help of an example. I will add few more points in the study material, so don't worry about it. It will be easier to explain. I will also give an example on that in that. So that's it from my side. Like so, space and time complexity will be this order of b to the power 1 plus c star divided by epsilon. So it's very important point. Okay, so I hope I've covered most of the things. Yeah, so that's it from my side. Try to solve this three example by your own. First watch this video, then try to solve this example by your own, and you can go to this particular point. Okay, so this is about the uniform cost search. I will add few more extra points in the study material, and I will also come up with very good questions, right, in the test series part. So very good amount of question can be framed from this particular topic. If you observe, we can frame any type of questions also, right, in this particular topic, right, from uniform cost search. So it is very important algorithm, I can say, for exam point of view. because good number of questions can be framed from this particular topic. So because it requires the concept of BFS also. So yeah, it's a very important algorithm. So try to go through the study material thoroughly. I will add one more example in that. Okay. So yeah, that's it from my side. And one more thing, we have already started the test series. Let me show you that. Yeah, so we already started our test series for GATE DA exam. So this is my website, piyushwairale.com. You can go to this particular website. And if you scroll down, whole fee structure is given, whole course schedule is given. So we already started with AI part, right? And yeah, so this is the fee structure. For AI, it will cost you around just 400. Lectures, tutorials, test series, materials, everything will be there. This lectures is available on YouTube, but tutorials will be on portal itself, only the portal, right? On this website only, that's it. And if you want to explore this, we have combo packages also. So you can just explore it, right? So I will add few more, so I will add few questions based on this particular uniform cost search. So you can just give and try there, okay? So that's it from my side. Thank you.